Amount of an annuity. There are actually two sections to this video. Finding the amount given all the other variables, and also finding the payment given all the other variables. Well, first of all, let's suppose $1,000 is deposited into an account at the end of each year for 50 years. Interest is 12% annual. Find the amount. So we're going to put a total of $50,000 into account just 1 year at a time. And make no mistake, 12% is a little bit generous. Over a lifetime of investing, you probably won't do that unless you're pretty aggressive about trying to beat the stock market. It would take you a considerable amount of time to do that. Some people have done it if they know what they're doing, but it would take a lot of work. Here's the amount formula. S equals R, 1 plus I to the n minus 1 over I. We're going to identify the variables. I'll do this on the same line. Well, $1,000 is the payment. And the rate in this case is 12%, 0.12. And n is equal to 50. Now we have to substitute. S equals 1,000 times 1 plus 0.12 to the 50 minus 1 over 0.12. And what I would recommend is figure out this first on a calculator. I can do this all in one big calculator set of operations, but it's more accurate to do it in a couple steps. And we get this expression right here. Well, we can replace this as 1,000 times, I end up with 2400 or 0.018. Okay, now the calculator steps for this are 1.12. You can add these two together. Up caret 50 minus 1 equals. Equals has it do all these operations. Divided by 0.12 equals. And this is what should come out of your calculator. Now we're going to do that times 1,000, and we get an amount of 24000. $18.25. Okay, that's all together $2.4 million. That's quite a bit of money. It seems like a lot, but this interest rate over a long period of time will accumulate quite a bit, and that's a pretty tidy sum, considering that you only put 50,000 in, gave you 2.4 million. Now we're going to turn this around. Suppose we need this same amount, 2.4 million, $18.25 in 50 years. It's kind of an odd amount, but suppose we wanted 2.4 million. I chose this obviously so we could work backward, and presumably so we could find this $1,000. At 7% annual, well, let's change this to 0.12 or 12%. Sorry about that. How much should we deposit at the end of each year? Well, we identify the variables just to get you in the right way of thinking. S is equal this. S is 240,018.25, and also I is 0.12, n is 50. And we're going to substitute 2,400,018.25 is equal to R. 1 plus 0.12 to the 50 over 0.12. And let's come up here front and center so we're not writing so low. Now what we're going to do is calculate this factor right here. I erased it, so I'll have to recalculate that. 0.12, 50 minus 1 0.12 equals. Okay, and we can rewrite this equation. 2,400,018.25 is R times, we replace that with 2,400,000.249. Okay. Now you can do the algebra, you can divide this by this number, divide this side by that number, or you can just do a quick step. You can just divide that by that to get R. You can see how we're going to get 1,000. There's a little bit of round off error here. I'll divide that out. And we ended up with 999.93 cents. Okay, it's supposed to be 1,000, but this is rounded off right here. And so I suppose if we hadn't rounded this off, if we kept more precision with this number, we could have come up with $1,000 exactly. But that's just because of round off error. But you see the general technique. So that's all for this video.